At the 2010 UN Framework Convention on Climate Change, attending parties agreed to commit to a maximum global temperature increase of 2 degrees Celsius above pre-industrial levels to avoid the most severe impacts of climate change. Represented in the figure above are different emission models, each depicting various levels of potential emission trends. Only the most optimistic predicts us escaping the 2 degrees Celsius barrier. With such a short amount of time before the threshold is met, emission reductions will be sought in the most readily achievable and economical of sources. This, we contend, at least for the United States, is easily found in the commercial building energy sector.
From a policy perspective, energy efficiency in buildings is the most lucrative potential source of greenhouse gas reductions. Consider that the United States accounts for 1/5 of the world's total energy consumption, and that 18.6% of that consumption comes from commercial buildings. This means that 4% of total world energy consumption comes directly from United States commercial buildings. The emerging scientific consensus is that the United States will need to reduce greenhouse gas emissions by 70 to 90% before 2030, possibly even by 2020, in order to avoid significant climate disruption. The social cost of carbon is a monetized estimate of the economic damages associated with carbon dioxide emissions. These costs include such factors as infrastructure damage from acid rain, medical costs from respiratory ailments due to smog, and so on. The social cost of carbon is currently estimated at $37 per metric ton. At current rates, commercial building CO2 emissions are costing the United States $38 billion per year. By 2035, this cost will increase to an estimated $69 billion per year.
In the graph on the slide, the uppermost line represents predicted global emissions if we continue with the business-as-usual approach and neglect emission reduction. In order to reach our target by the year 2050, various mechanisms must be utilized, as represented by the colored wedges. It is important to note that energy efficiency improvements represent 50% of the total global emission reduction, proving a most useful and necessary tool. On the potential greenhouse gas reduction from enhanced building efficiency, the LEED rating system has established some groundwork. The Leadership in Energy and Environmental Design, or LEED for short, rating system certifies projects on a points-based system, awarding certified, silver, gold, or platinum certification. These points are awarded based on 6 categories: sustainable sites, water efficiency, energy and atmosphere, in which emission levels are considered, materials and resources, indoor environmental air quality, and innovation in operations. The main drawback to this system is that project owners often play a points game and earn the points in order of affordability. In doing so, they earn their LEED certification, but often display emission levels higher than that of similarly sized buildings that are not LEED certified. Lastly, it must be noted that LEED certification is not an efficiency standard, but a green building standard. In the global effort to advance energy efficiency, LEED is most certainly necessary, but not sufficient.
50 by 30 is part of a long-term energy strategy. We are proposing a nationwide, long-term goal of an 80% reduction in greenhouse gas emissions by 2050, equal to standards recently adopted by New York City, the state of Massachusetts, and the United Kingdom. Creating a federal incentive program for energy efficiency in commercial buildings is the most efficient method of achieving these forward-thinking energy use reduction goals. Pursuing an aggressive national emissions reduction agenda positions the United States as a world leader in counteracting climate change. Our plan is two-part: ensure access to capital for energy efficiency upgrades and provide tax incentives to incentivize the achievement of energy reduction goals. The Commercial Building Energy Efficiency Program offers building owners access to capital for energy efficient upgrades through government-backed loans. To qualify for a loan to this program, property upgrades must achieve at least a 20% energy use reduction compared to a building meeting minimum requirements set by ASHRAE Standard 90.1 TAC 2001. Property owners must also submit projections of energy efficiency improvements using government-approved modeling software. Those achieving energy cost reductions of over 30% are rewarded with tax benefits. Tax deductions are designed to completely cover upgrade costs and are inclusive of energy cost savings. Some characteristics of our program are that it is concerned with conventional versus deep retrofitting. It synchronizes with municipal government's PACE financing legislation. Energy efficiency improvements are compared to the ASHRAE standard 90.1 baseline. It is also technology neutral, a precedent set by the Energy Policy Act of 2005. To incentivize energy efficiency upgrades, 50 by 30 provides tax incentives designed to assist in recouping the cost of upgrades borne by property owners. Total compensation is calculated on a graded scale from $2 per square foot to $4 per square foot, where a 30% reduction in energy usage earns a $2 per square foot tax benefit, a 40% reduction in energy usage earns a $3 per square foot benefit, and a 50% reduction in energy usage earns the maximum benefit of $4 per square foot. Incentives are calculated with a combined compensation model, where the total benefits combine both energy cost savings and tax benefits. Energy cost savings are calculated using energy use reduction percentage, with an average energy cost of $2.50 per square foot. For example, a 30% reduction in energy usage is eligible for total compensation equaling $2 per square foot. Based on our assumed energy cost of $2.50 per square foot, 30% energy savings will contribute 75 cents to the total, and the remaining $1.25 of eligible compensation would be covered in the form of a tax deduction. In this manner, efficiency upgrades can be completely paid for by our recoupment plan. Currently, our energy efficiency market is in imbalance. There is a supply shortage of energy efficient buildings compared to the social benefit available from energy efficiency. Our proposal seeks to internalize this positive externality by incentivizing energy efficient upgrades in a method where businesses get paid for energy efficiency. This shifts the marginal private benefit curve closer to the marginal social benefit curve as more energy savings are realized. This allows us to leverage the potential of this positive externality so that the benefit of increased building efficiency is shared by all. The primary economic effects of 50 by 30 include reducing businesses' energy costs, which would result in an aggregate benefit of $85.6 billion in 2030, based on achieving a 50% reduction in energy costs over 2005 levels. 50 by 30 also helps to create jobs and grow the green construction industry by increasing demand for green building professionals in a variety of capacities. Secondary economic effects of our policy include decreased economic impact from the social cost of carbon, such as a reduction in property damage from flood risk and reduction in danger to human health. Other secondary effects are a possible increase in interest rates due to increased demand for capital. Our policy would have an unknown effect on energy prices due to the complexity of changes in the energy market that would result from a reduction in demand.
The first and most pervasive constraint is an institutional one. The nature of commercial buildings in the United States is such that 35% of floor space is in the largest 2.2% of buildings, while at the other end, there are many small businesses occupying a relatively smaller space. This market segmentation makes collective action a more difficult feat. Secondly, the prevalence of PACE legislation in municipal governments will aid in the appropriation of upfront capital. Property Assets Clean Energy, or PACE, financing is a municipal tool that allows property owners to finance energy efficiency projects as a property tax assessment in which the debt is secured as a lien on the property. This helps projects attract private capital. Where this legislation is in place, it will be less burdensome on the federal government to back loans as promised. Lastly, on the possibility of imposing unfair regulation of green certification companies, we have deduced that the risk is unfounded. Citing precedents of IRS Tax Code 179D, commercial buildings based on energy cost improvements, were able to recoup costs via tax breaks up to a maximum of $1.80 per square foot. Like our proposal, Tax Code 179D set energy use standards not in line with those in use by the largest green building inspector, LEED, and laid out simple guidelines. In order to claim a 179D deduction, certification must be done by a qualified inspector who is an unrelated third party using government-approved software. Not only does this avoid unfair regulation on the LEED rating system, but also helps maintain capitalistic competition and avoids the creation of a natural monopoly. In fact, since we are setting a nationwide standard, we believe that it will be in LEED's best interest to align their standards with ours and allow buildings to reap the benefits we promised through the LEED program. Achieving 80% greenhouse gas emission reduction by 2050 is an ambitious goal that warrants ambitious action.
50 by 30 is that action. Thank you for your time, and we hope you enjoyed our presentation.